Mindsetters, grade 12s, you guys have been so excited to finally have your show for 2014, your very first live show. So it's finally here. I am Looney, and joining me in studio is Lee.
Hi everybody, nice to be with you.
How are you doing?
No, very well. I hope they're sending you lots of questions to keep us
They've
busy.
been excited since like 4 o'clock, so I'm sure they're ready to send you all the questions.
That's
What do
great
you have for
news.
the matrix today?
We are going to work on sequences and series today.
All right.
And basically this is the first of the sessions. So
All
we're
right.
starting with that, and then next week we continue on to a little bit harder, or not even harder really, just different work.
All right. Mindsetters, you heard it. Part 1 of sequences and series. So grade 12, you've been hitting me up on the Facebook page since the grade 10 show. So I know you guys are on the page and you know where to follow us at Learn Extra on Facebook and on Twitter. And to visit our website, to go to learn.mindset.co.za. And with all that said, it's time for your show, guys. So Lee, take it away.
Great. Okay, now as you know, we're going to revise calculations for arithmetic and geometric series. So before you even start to think about it, this is not new to you. You started working with sequences a long time ago. In fact, already in grade 8 you worked with it. And slowly we formalized it, and now this is the culmination of it. So we start off with things, and we used to talk about a first order difference and a second order difference, the quadratic and the linear. The linear, the first order difference, is actually your arithmetic sequences, so it's not a big surprise for you. So let's have a look at what we have here. Right, and then we're going to look at the revising of the two things. Let's have a look at the first one. First of all, let's look at the formulas you should know. It's assuming I can remember how to do this. Oh wait, I went a bit too fast. Sorry, got carried away. All right, let's go down to our formulas. Oh wait, sorry, I'm nearly forgetting the most important thing. Sorry guys. The challenge question. Now this was sent in, as you can see. The following sequence is a combination of an arithmetic and a geometric sequence. And I've just got to make sure my pens are working. And they are not. That is just such fun. Don't know why. Let's use my finger. No, that doesn't work now. Anyway, it's a combination of an arithmetic and geometric sequence. It goes 4, 4, 10, 12, 16, 36. And they ask you to calculate the 37th and the 38th term. The question was submitted by Pamela to the Learn Extra Help Desk. Lovely little question. I want you to start thinking about it and seeing if you can solve it. Later on we will discuss the question, but let's give you some time to give it some thought. Okay, let's move now on to the actual theory. Right, now as I said to you, we're talking about an arithmetic and a geometric series. And as I said to you, an arithmetic was known as a first order difference. Now I just need to get this pen to work, and oh yes, here we go. I've got it right now. Okay, so let's have a look at it and talk about it. If we're looking at this, we're talking about an arithmetic. Now before we even start, let's talk about what is the difference between a sequence and a series. Now with mathematics, I'm sure you know that the terminology we use is extremely important. So if I start talking about a sequence, this is what I mean. If I can get this to extend, I mean, let's take the first term and then a semicolon, the second term, and a semicolon, the third term, and so on and so forth. Right, and then if I'm talking, that's a sequence. And if I'm talking about a series, well, now I'm saying, let's take term 1, add it to term 2, add it to term 3, and keep on going as long as we need to. So when we are adding or summing the sequence, we are actually calling it a series. Of course, we could also have an add and a subtract depending on what sort of sequence we're working with. Back to our formulas again, just for a short while. And what is very important is to know that an arithmetic sequence has got a constant difference. In other words, to move from one term to the next, I will constantly add something. Now you'll see in the formulas here, I say D is equal to T2 minus T1, or D is equal to T3 minus T2. And in fact, it's any two consecutive terms. So if I had known term 7 and term 8, I could find the difference by saying term 8 minus term 7. It doesn't have to be in particular the ones I've mentioned. Okay, so that's the first thing that is important. And then we have a geometric sequence which has what we call a constant ratio. Now that is the new one to you in matric. And basically what that one is saying is in order to move from one term to the next term, we have to multiply by something. Now, we could multiply by a fraction, which in effect could be division. So we are saying like something like 2, and then the next one would be 6, and the next one would be 18. So what am I doing? I'm saying 2 times 3 gives me 6, 6 times 3 gives me 18, and that would make it geometric. Now, to find the constant ratio, the formula we use there is that the ratio equals term 2 divided by term 1, or the ratio equals term 3 divided by term 2. And again, if I knew term 7 and 8, I could say term R is equal to term 8 divided by term 7. So it's any 2 consecutive terms. It doesn't have to be 1 and 2 or 3 and 4, anything. It can be any 2. Now, we're going to talk about that in a moment, and I'm going to show you how that works. And in fact, let me do it right now before we even go on to the next formula. Let's take a sequence. Let's take 3, 5, 7, 9, etc. And I was asking about that back in the good old days when maths was easy. You would have looked at it and you would have said, well, look, I've gone from here to here by adding 2. I'm going from here to here by adding 2. And I'm going from here by adding 2. So this would be a first order difference. Now all we're going to do is call this an arithmetic sequence. Okay, where the constant difference is 2. Let's look at another one. Let's take 7, 4, 1, etc. Well, what are we doing each time to move along? Well, as we've moved from 7 to 4, we've actually subtracted 3. And to move from 4 to 1, we've subtracted 3. Again, it's an arithmetic sequence, and the difference is equal to, well, each time we are subtracting 3, so it's negative 3. So that's how we would establish it, but this is not foreign to you. You've already done first order difference, which, as I say, is just called an arithmetic sequence. Now let's take one more. Let's take a geometric now. Let's take 1, 4, 16, 64. Now if you look at that, the difference between there and there is 3. The difference from here to here will be 12. So immediately you can see it's not working, but you actually think to yourself, I know, saying, well, maybe it's a geometric. Well, yes, it could be, and in fact, in this case, it actually is, and not a geometric, a quadratic. And if you have a look over here from 16 to 32, it would be a nice big difference. But if we look at it now, I can see that if I times by 4, I will get 4. If I times 4 by 4, I will get 16. And if I times 16 by 4, I will get 64, which means my R, remember, is determined by taking 4 divided by 1, term 2 divided by term 1, or 16 divided by 4, which again will give me 4, or it could even be 64 divided by 16, which again would give me 4. So I have a constant difference of R, of 4. I'm not difference, a ratio of 4. Let's take one more just to show you it could be a fraction. Let's suppose I had 12, and then I had 6, and then I had 3, etc., etc. Now, if I look at it, the difference from there to there would be negative 6. The difference from there to there would be negative 3. So we know it's not going to be arithmetic. But if I look at this and I take 6 divided by 12, which is term 2, divided by term 1, I would get a half. And if I take term 3 divided by term 2, my answer is also a half. So yes, constantly I'm getting an R of a half, which means that I have a geometric sequence. So that is very important. And when we start handling the questions, I'll give you a format that makes sure that you don't go wrong. Right, let's go back to the formulas. And you can see we're now moving into this formula here. Now, when you learned first order difference, the teacher may have shown you that formula, but maybe not. And if they didn't, that's also fine, because in actual fact, it's sometimes easier to do it the other way. So it's not a wrong thing to do at all. Now, basically, this formula is very useful, and it entitles you to work out any term. And then you have the geometric equivalent. Now, you might notice what I'm doing is I'm putting them together. And I want you to do that as well. I don't want you to think to yourself they're something different, because they aren't. It's different sequences and different formula, but the way we do them is almost identical. And then we have the next formula, which is Sn. And just over here, I can add something. There is another formula that goes Sn equals n over 2 a plus L, where L stands for the last term. Now, I must just tell you that that one is only useful if we know the last term, but often we do. Not often, but sometimes we do. So if you wanted to use that one, it is as good as the other one because the last term would be considered term n. So let me explain to you what I mean by that. Term n is a plus n minus 1d, as we've just seen. Now, if you replace that there, a plus n minus 1d, you'll get exactly that formula. So it's not a really difference, it's a derivative of that same formula. In fact, normally we'd get this one when we're proving, and then we'd move by substitution to that one. So again, the same formula, but very useful to know. And over here we've got these two formulas, and once again you could manage with either one of them. But there's one that's easier than the other. Over here, if r is greater than 1, it's best to use this top one, because it avoids some horrible negative numbers. And if the bottom one over here, if r is less than 1, it's better to use this bottom one. But in actual fact, if you use the wrong one, it just means you're making your arithmetic a little bit more difficult. But in actual fact, it's not much different. And then the one we're going to spend a lot of time on next week is this one. We won't see much of it tonight. The sum to infinity is equal to a over 1 minus r. Now that one brings a whole lot of interesting things in, around convergence, etc., but we will discuss that next week. We won't look at it now. So right, let's have a look at the first question, and let's start to put this all clearly in our minds. It says, given the arithmetic sequence. So now what's nice about this question? Whenever you get a question in the exam, read it and highlight what's important. They said, given the arithmetic sequence. So if they're telling me it's arithmetic, I already know that I am working with either Tn equals a plus n minus 1d for the term, or I'm working with Sn, n over 2, 2a plus n minus 1d. Because they've told me it's not geometric, they've told me it's arithmetic. Now we go to the sequence. And the sequence there says 23 plus 23 comma 27 comma 31. So if I look over here, if I look here, 23 to 27, I'd have to add 4. And here I would have to add 4. So yes, it is following what they said. It is arithmetic. Now what I'm doing is what we call coding. So I'd say it's arithmetic. A always stands for the first term. Now the first term here is 23. And the d, as we found, is the common difference, which we found to be 4. And what I've done is I've actually written in code, or in symbols, what I know about the sequence. Now, what's the question asking me? It asks me to find the 27th term. Now, why I liked this question is it brings home some little thing that everybody has trouble with. It says the 27th term, but there is a term that is 27. And that seems to confuse people, so don't let it confuse you. It's something we can avoid confusion on. If you look at that, that is actually term number 2. Because if I'm looking at it, this would be term 1, this would be term 2, and this would be term 3. So in actual fact, term number 2 is 27. But we are asking here for term 27. So in other words, if I kept on going, I would get eventually to term 27, and that's what I'm trying to find. Now, as soon as I've decided that, as again, it's what I call coding. Sorry, I just want to make this extend if it'll behave itself. What will term 27 look like for an arithmetic progression? Well, we know that it's going to be a plus n minus 1. Do we know what n is? Yes, n is 27. And over here, in fact, we could say n is 27. So it'll be 27 minus 1 times the difference. But the good news is we do know what a is, and we do know what d is. So if we go over here, the a is 23. 27 minus 1 is 26, and the difference is 4. So that's not difficult at all, because now I'm going to say this would equal 23 plus 4 times 26, which is 104, I hope, which is going to equal 127. I hope I've worked that out correctly, but I won't check it. I think it is right. If anyone thinks I'm wrong, please go and send to Facebook and say you've done that incorrectly so I can check the arithmetic. But I think I'm right on that. So in other words, term 27 is 127. And it seems like whoever designed this question really liked 27 in it. Okay, so now I think we're almost out of time for this section. So I'm going to carry on the second part of this question after the break. So I'm going to pass back to you and we'll go to the second part.
All right, thank you, Lee. Mindsetters, let's take a very quick break and we'll see you straight after this. Welcome back, Matrix. I know you probably like the sound of that word, Matrix. You're finally Matrix. We're back for your maths lesson with Lee, so I won't waste any more of your time.
I hope they like that sound in about September this year.
No, they will. I mean,
They will.
come
It'll
on.
be such an exciting year. So just apply yourself from day one and it'll be good.
Yes.
Right, so we were busy with this and we had talked about term 27. And now they turn around and they say something new. They say, which term equals 243? Right, so which term, so they want to know what term n is equal to 243. Now, what does term n look like? It is a plus n minus 1d. Now, what you'll always find with these questions is that there is at least, well, there always will be one thing you're looking for, and you will have all the other details, even if they be disguised. This one's not disguised because we've already done the A part, where we found our A and our D. So if we go over there to the A part, I think our A was, if I remember rightly, yeah, it's not too far to look. A was 23, and the difference was 4. So we know that information. What we don't know this time is what the nth term is. So we can say 23 plus, and as I've said to you, the unknown is this bit. So we can go open brackets n minus 1 times the difference, which is going to be 4, equals 243. Right, now, all we've got to do is solve this. Now, you know, you've got a choice of two ways here. The best way for me is not to multiply out the bracket. But if you prefer it, I'll show you both, and you can decide what you prefer. I think I'll show you, first of all, how to do the one where you don't unpack it. So what you would do is you would leave your n minus 1 alone, and your 4, and you would bring your 23 over the side. So now you have n minus 1 times 4, and if you take 243 minus 23, it's going to be 220. Right, now once we're here, we can see that in order to lose that 4, I need to divide this side by 4 and this side by 4, because after all it's an equation. So we have n minus 1 equals 220 divided by 4. Well, 4 goes into 22 5 times, that's going to be 55. And of course your calculator can help you, but I just want to encourage you to start very early to try and work without your calculator. If it means you're going to get the question wrong, then rather use the calculator. But certainly in your classwork, I'm encouraging you to try and work without the calculator, because all these tests that you do for university, you know, as NBTs and that sort of thing, rely on you not using a calculator. And it's also good for your mind, to stimulate your mind, to try and use your mind rather than a calculator. Right, so n is equal to 36. So what am I saying to you? Sorry, not 36, 56. I'm saying to you that term number 56 is 243. Okay, in other words, if we looked along this little list of delightful terms we've got here, eventually we'd find 243, and that would be term 56. So just don't get confused when I give you the term of 27 versus the 27th term. Right, let's look at another question and see what this one has for us. Now this one says, find the sum of the following finite series. Now before we even start, what does finite mean? Well, hopefully you're all screaming at the TV. Finite means ending. Infinite would mean non-ending. Okay, so if I talk about an infinite series, I'd be saying that this thing carries on forever. But this one doesn't. Have a look at what it does. It stops at 122. So that's why they say it's a finite series. Do they say to me what kind of series it is? No, they don't. They just say it's a finite series, find its sum. So immediately what I said to you is, remember, read and circle or highlight what's important. So they're asking for the sum. So that means we're either working with this formula or we are working with this formula. And remember what I told you about this formula? There are two possible ways we can write it. So I'm just going to write one down for now. How we decide which one we're going to use is by deciding what type of sequence this is, or series in this case, because we've got add signs between it. So if we go to it here, it starts in, it says 2 plus 6 plus 10. So I would always check first for an arithmetic. So I'd say if I move from 2 to 6, what am I going to get? And hopefully you realize that I would add 4. If I move from 6 to 10, looks like I'm in a winning streak. I'm also going to add 4. And once again, I'm going to add 4. So that decides me that it's not a geometric, it's an arithmetic. And now I just want to spend a few seconds talking about your formula sheet. The formula sheet is a very useful thing. But as matric, speed is important. So something that you use a lot, like these formulas, it often is a good idea to just know these formulas. And if I'm not much mistaken, I think when you write those NBTs for university and that, they don't let you have a formula sheet. I might be wrong on that. I'm not convinced I'm right there. But in actual fact, if you know your formulas, it's always easier to work with. What I would do with my formula sheet is I would keep it for in case I forget. Because, everybody can have moments like that. But if I know it, I'd rather put it down. If you are kind of the person that will make a mistake, rather check it. Always just know your strengths and weaknesses and then use it to your advantage. So as I've said, it's arithmetic, so that is the formula I'm going to use. Now, what is in this formula? We have an A, we have a D, and we have an N, and we have an SN. So what are they asking me? They're asking me for the sum. Now, do we know N? And I hope you're saying, no, we don't. Do we know D? Yes, we do. D is 4. We've worked that out. Do we know A? Well, the A is the first term. Yes, it's 2. We know that. And we asked for the sum. So do we know that? No. So we have a problem. Of the 4 things in this formula, we only know 2 of them. So we must have a way to work out the third one in order to use that formula. Now, looking at this, what can we still work out? We've got A and we've got D. We don't know what N is. We're asking for the sum. They're asking for that, so the chances are we have to work out that. Now, how do we do that? Well, we know that this is term number 1. We know that this is term number 2. We know this is term 3. This is term 4. And in actual fact, this must be term N. Because if I was saying to you the sum of 5 terms, it would mean take term 1, add it to term 2, add it to term 3, add it to term 4, add it to term 5. So I would stop with what the number is. So that is term N. Now, does that help me? Because I've got a formula for term N. What does the formula for term N look like? Well, let's just get some space here. I'm just having some fun dragging this down. There you go. Well, this formula would be Tn equals A plus n minus 1d. And what do I know on this formula? Well, I do know A, as we've said it's 2. We don't know n. We do know d, it's 4. But do we know this? Yes, we do. It's 122. So we're going to put 122 in there. Now, knowing that, we only have one unknown, which is n. If we solve that n, we can then go to the other formula, because now we know 3 of the 4 things. So what helps is to put on the side what you need to find and then to say, what have I got? And it helps you direct yourself. So over here we have 122 minus 2. And remember what I said to you about the n minus 1 times 4. This time I will show you the other way as well. So 122 minus 2 gives you 120 equals n minus 1 times 4. Now, as I said to you, you would have a choice of doing this one of 2 ways. The first way is the way I would do it. I would say, let me divide both sides by 4. So 4 into 120 goes 30 times equals n minus 1, so n is equal to 31. The other way is to say, well, this is 120 equals 4n minus 4, which means we have 120 plus 4 equals 4n, which means we have 124 equals 4n, which means we can divide both sides by 4, and that's going to give me 31 is equal to n. Now, as you can see, it made absolutely no difference which way I did it. The one was just a bit quicker. But it's really about what you're comfortable with. If you're one who prefers to times out and then simplify, that's fine. Nothing wrong with it. I prefer to work with the bracket as a unit. It just makes it easier for me. But it's really your choice. You're the person who has to write that exam. Right, so back we go to the actual question we were asked for. We were asked for the sum, but we now know that this answer over here is term 31. So we know that A is 2, D is 4, and N is 31. So let's go on with the question. This board has been very unobliging when it comes to paging up. There you go. So as I said to you, Sn is n over 2, 2a plus n minus 1d. Right, so now in the light of that, let me just erase this little mess over there. In the light of that, we are looking for the sum, and we know there are 31 terms. We don't know what it is, but we do know that the n is 31, so it's 31 over 2. 2 times my a, which I think was 2 if I remember right. Let me just make sure. I'd hate to tell you how it is 2. 2 times 2 plus, now this is n minus 1, well it was 31. 31 minus 1 is 30. And again, you don't have to miss steps. I am inclined to do that because it actually looks easier to work with if you do it like that. But really don't miss steps if you're not sure. Right, so now 2 times 2 is 4, and 30 times 4 is 120. Right, so now once we're here, okay, let me just get this to extend again, and I see it's been very obliging. Right, here we are. So it's 31 over 2. Now notice what I'm doing. I'm deliberately not multiplying it in. I'm leaving it like it is. I'm going 31 over 2, and I'm going to work out my bracket first of all. So 4 plus 120 is 124. Now why did I do that? Because it makes my arithmetic a little bit easier. I've got 31 over 2 times 124 over 1. That goes once, and into there it will go 62 times. So I want 31 times 62, and now I'm going to be lazy and use the calculator. I think that's a good reason to use it at that stage. So it's 31. Okay. Obviously I'm doing something crazy with this calculator. Okay, it doesn't look like the calculator and I are going to get on. Anyhow, it's 31 times 62. Since the calculator won't work for me, let's use my brain if all else fails. So we got 62 if I times by 1, and if I times by 30, it's going to be 6, and that's going to be 18. And if I add that up, it's 2, 2, carry the 1, 9, 1. So I end up with 1922. Okay, and that's the end of the question. Have I found the sum of 31 terms? Yes. Do I like that question? Yes, I do, especially if I'm an examiner, because I've tested, do you understand what that last term stands for? And second of all, I've tested, can you do a term and a sum in the same question? And can you identify what kind of sequence it is? So I think it's a great question if you're the examiner. Right, let's look at the next one. We probably won't get too much into it, but maybe we can have a look at it more closely. Question 4. Right, now this one again, it says the fourth term of an arithmetic series is 55. Now the word series has been used, so what does that mean in your life? It means term 1 added to term 2, added to term 3, etc., etc. Does that matter if I'm adding the terms? Can I still identify the fourth one? Yes, I can. So it doesn't make a difference to the question. The fourth term, so they're saying the fourth term. Now, as I said, your coding is what we use. So the fourth term, so T4, is 55. So what I've done is I've just changed this whole sentence into code. And the 10th term is 45. So now I'm going to change that to code. And the 10th term is 45. So T10 is 45. Did they tell me what type of series? Yes, they did. They said arithmetic. So if it's arithmetic, we know already what formula we need. We need Tn equals A plus N minus 1D. Okay, now it says find N if, and I think there's something missing there. I think it should have been Sn. I think it's Sn. I hope I'm right. Is less than naught. Sorry, I didn't notice that missing on the notes. So I think it says Sn less than naught. Right, so let's have a look at it. And what we're going to do, well, we know it's arithmetic. We know that's how the formula looks. So the first thing I want you to do is while you have a break, which will happen shortly, is to try and do it yourself, but I'll set you up to start. So what will term 4 look like? Well, you can go back to that, but I get a bit lazy after a while. I say I know that every time I have a arithmetic series, there's one less difference than the number of term. So if I'm looking at term 4, it's going to be A plus 3D. And of course that's possible because the 3 comes from 4 minus 1. And term 10, well, that's going to be A plus 9D. And if we do that, we can see where this question is going to go, I'm sure, because you're going to try it while you have a break shortly. We are going to know that 55 equals A plus 3D, and 45 is equal to A plus 9D. So how many unknowns have we got? We've got all of these. We know those. We know those. What we don't know are those. Now, if we've got 2 unknowns and 2 equations, I want you to think about it during the break if that's going to be any problem at all. Yeah, let me hand over for now.
All right. Mindset is, let's take a quick break. But before we do, guys, I see some of you are asking me through the messages when sub school is. It does start at 9 o'clock. It started today. So it starts at 9 and then it goes the whole day. Then we take a break because of the live shows. Then at 7 again, it picks up and it carries on. So sub school, if you know any of your friends who were in matric and who want to sub some of their subjects because they didn't do so well and they're preparing, we help them prepare through all those times that I just mentioned. So let's take a quick break and we'll see you straight after this. Welcome back, Mindsetters, from your break. Lee.
Nice to be back with you. I can't believe how quickly the time has gone.
It's flying.
So, I'm trying to get as much in, and we've got a nice question which I'm hoping I'll still get time to get to. I will try to remember to put it in. Anyhow, what we're going to do here, we were there and I left you there, and hopefully in the break you had a chance to quickly look at it and realize that if I call this equation 1 and I call this equation 2, I can solve simultaneously. So I could take equation 2 minus equation 1. Now, you can, of course, make A the subject of the formula and substitute, but I find with arithmetic sequences, the best thing to do is elimination. So what I would do is I would say 45 equals A plus 9D, and straight underneath it I would go 55 equals A plus 3D. Now, I'm going to subtract those expressions. 45 minus 55 will be negative 10. A minus A falls away, and 9D minus 3D is going to be 6D. So now, if I want to work out this next bit, I would know that D is equal to minus 10 over 6, which is minus 5 over 3. Right, so knowing that, that's fabulous. Now, all I have to do is go back and get the A, because now I've got the D, and I have to go back and get the A. Now, it's up to you. In this case, I probably would go for equation number 1, because a 3D is going to be easier to multiply than anything else. So I'm going to substitute in equation 1. Notice how I'm giving my marker instructions. So I'm telling the marker, this is what I'm doing, and it helps them to follow my thinking. And I'm sure you've been well trained in that, because most teachers will nag you for that one. Okay, so what I'm doing here is I'm going to say 55. Oops, that's what happens when you touch the screen when you're writing. 55 equals A, which is what I'm looking for, plus 3 times the difference, which is minus 5 over 3. Now that's 3 over 1, so that 3 divides into that 3. And now I have 55 equals A minus 5. Very nice, because even if I'd used the other one, 9 times 5/3, the 9 and the 3 would cancel down, and so it would make it easier to work with. So it's a good question. It's not going to cause huge problems in terms of our arithmetic. And so our A is equal to 60. So now I've got A is 60. D is negative 5/3. And I need to go back and just make sure I've answered the question. Always check that, because you can sometimes get carried on. We haven't. It said find n if Sn is less than 0. So let's go to the actual thing now. They want Sn less than 0. Right, so now they're solving for n. Sn is n over 2. We obviously don't know what that is. We do know A is 60, so it's 2 times 60. Plus n minus 1, we don't know what it is. And the difference we do know, which is minus 5/3. In fact, I think it's Tn. In fact, I'm pretty sure it's Tn. Sorry, I'm going to change it because I'm sure it's Tn. I meant to check that in the break and then didn't. But it's fine. It'll serve the purpose we want anyhow. So let's make it Tn less than 0. So Tn is going to be A plus n minus 1 d less than 0. Now, A is 60. N is what I'm looking for. And the difference is minus 5/3. And my advice to you is keep that in a bracket, because you don't want to get confused about whether you're multiplying or you're subtracting. So if you put it in a bracket, you are sure that you are multiplying. So once we are here, we're now ready to solve it. Now, what I would do in this case is I would multiply the whole thing through by 3. So if I do that, 60 times 3 is 180, plus n minus 1, and if I times by 3, it's just going to be minus 5. And of course, if I times 0 by 3, well, that's what it is. So what have I got? I've got n minus 1 times minus 5, and I'm going to bring this over as minus 180. Now, this is a great opportunity, because if I divide both sides of an inequality by a negative number, we know that the inequality reverses. Remember back to the good old days when maths was easy? No, I'm only teasing. It's easy still. We just got to keep it going. If I had 3 is less than 6, and I divided both sides by negative 1, well, I get minus 3 and I get minus 6. And would that still be true? No, it wouldn't. It would be that way, because a negative 3 is bigger than a negative 6. So we just remember the rule. If we are dividing or multiplying by a negative, reverse the inequality. But if you're never sure, just do a little sum on the side and make sure in your mind why you're doing what you're doing. So what I have now is n minus 1 is less than changes to actually greater than. In fact, I'm going to change the color pen to distress the point. And if I now take minus 180, divide by minus 5, it will be positive, and it would be 30, and that would be 36. So your n is greater than 37. And once again, you could times it out and then collect it. It would make no difference. And so I know that n is greater than 37. So only after the 38th term would it be less than 0. So as we're going, we're only going to start becoming negative at that stage. Right, now at this stage, before I carry on with the examples I've chosen, I want to go back to our challenge question, because by now you've had some time to think about it. And I don't want to leave you up in the air about that question, because it's a lovely little question. So let's look at it. Oops, I think I pressed the wrong button again. There it is. Right, so let's have a look. Let me just get some space on here. So we're certainly going to need space for this question. Now, it's not a hard question if you understand what they're getting at. The following sequence is a combination of arithmetic and a geometric. Now, we haven't started to work with any of the geometric yet, but we should get to it shortly. And it's the terms are 4, 4, 10, 12, 16, and 36. They ask you to calculate the 37th and the 38th term. Now, for me, that's a little hint, because 37 and 38 probably means that the odd terms are doing one thing and the even terms are doing the other thing. That's usually that. Sometimes they get carried away and they'll have, say, one term and then they'll have two belonging to the other, and the one term and then two belonging to the other, but that's rare. This is more like it. And in fact, if you look at the multiple choice questions attached to this lesson, you'll see another one very similar to this, so you'll get a chance to practice. So if we look at this, this is term 1. This is term 2, this is term 3, this is term 4, this is term 5, and this is term 6. So if we look at it, they want the 37th, which would imply the odd term, and the 38th, which would imply the even term. So let's separate them out. Let's take the odd terms. So that would be 4, 10, 16, etc. And then let's take the even terms, which would be 4, 12, 36. Now let's see if that helps us out. If it doesn't, we go back to the drawing board. But as I said to you, I think they are trying to help you out by telling you that information. Now if we look at the purple one first, they're telling me 4, 10, 16. Well, what I noticed, to move from here to here, I added 6, and to move from here to here, I added 6. So that appears to be an arithmetic sequence. In fact, it is, because it wouldn't have a constant difference otherwise, where the D is equal to 6 and the A is equal to 4. On the other hand, if we go to the orange sequence, certainly if I add, I would get 8, and if I added there, I'd get 24. So that would be a problem. But let's look at multiplying. If I look at this, multiplying by 3 would bring me to 12. And if I multiply 12 by 3, it would bring me to 36. So that appears to be a geometric sequence where your A is 4 and your R is 3. Now, they've told me it's a combination of an arithmetic and geometric, and good news for me, it's worked out really nicely because I know that. Now, let's go back to it. If I'm looking for the 37th term in the sequence, but I've divided the sequence into two parts, what do I notice? Well, if I look here, these two make a pairing, if you like, arithmetic geometric, arithmetic geometric, arithmetic geometric. So if I keep doing that, term 37 and term 38 will be a pairing. And if it's a pairing, that would be the first term, if you like, of each of the terms, the second term of each of the terms, the third term of each of the terms. These two must be the 19th term of each of the terms. Let's think about it again, because it's not so easy. Over here, I said to you, this one here is term 1 of each of the terms. Well, if I look there, term 2 divided by 2 is 1. This was term 2. Well, 4 divided by 2 is 2. And over here, this would be term 3. So it seems to me as if I get the number position by using that last one. So over here, if I'm using this one and I'm dividing it by 2, this would be term 19 of each of the sequences rather. So what I have to do is work out the 19th term of the purple one and the 19th term of the orange one. So let's have a look and see how we go. Let's start with the purple. That's going to be easy for us because we've been doing a little bit of this. Term 19 is A plus 18D. Do we know A? Yes, we do. It's 4. Do we know D? Yes, we know it. It's 6. So that's going to be 4 plus 18 times 6. So that's 8 carry the 4, 108, I hope, which is 112. So we got that nice and easy. So term 19 of this purple series is actually term 37 of the original. Okay, now that's the part that gets a little tricky. If you can keep that straight in your mind, you're winning. Now over here it's a geometric. And to find a geometric term, we use Tn equals A, R to the n minus 1. So do we know A? Yes, we most certainly do. Do we know N? Yes, we do. It's term 19. So it's going to be A, which was 4, your R, which is 3, to the 19 minus 1, which is actually 18. Now, there's no way I'm going to work out 3 to the 18 without a calculator. Please believe me. So let's get the calculator up. And we're going to say 3 to the power 18, or to the, oh, no, that wasn't very clever of me, to the exponent 18 equals, and then I've got to times that, was it by 4? I think it was, yes, by 4. And that gives me the answer, which is hideous. You can see it's 81956. Now, to write that up will take me a few seconds, so please forgive me if I have to do this slowly. It's 154. Let's pull the calculator up again. 968. 968. Pull the calculator up. 1956. That'll make life easy for me. 1956. Okay, and that's the answer of term 19 of this one. But remember, of the original, it would be term 38. Nice little challenge question. Thank you very much for sending it through to the desk. It's a lovely question. Right, let's move on to the next question. Let's see how far we can get. Even if I just set you up on the question, we will try to cover whatever I didn't manage to do today a little bit in the next one. Uh-oh, I keep doing this to this poor thing. Okay, here it is, question 5. And as you can see, this one is a geometric sequence. Is it nice? Yes, it is, because they've told me it is geometric. And so remember what I said, you always look for the important cues we find in the words. So if we look over here, this is geometric. That's term 1, term 2, term 3, and it's geometric. And they want you to determine in simplest exponential form, which is good news, which means I don't have to dig out the calculator. I can leave it as an exponent. Term 11, and which term equals 2, 4, 5, 7, 6. Now, term 11 would be A, R, to the 11 minus 1. Remember what I said to you when we were doing arithmetic? I said the difference is always 1 less than the number of the term. Well, this time the exponent is always 1 less than the number of the term. So in actual fact, term 11 is A, R to the 10. Right, so the A would be 3/4. And R we haven't ascertained yet. Now remember, we can just look at it and say, what are we doing, and work it out like that, but we can also use the formula I've shown you. In other words, R is equal to term 2 divided by term 1, which is 3 over 2 times 4 over 3. That goes once, that goes twice, that goes once, that goes once, and the answer is going to be 2. So R is 2, so it's 2 to the 10. Now they said you leave it in exponential form, and so if we do that, it's going to be 3/4. Well, in fact, yeah, let's just leave it like that, 2 to the 10. And what do we know about 4? Well, 4 is 2 squared. So it's 3 times 2 to the 10 over 2 squared, which is going to be 3 times 2 to the 8. And that's perfectly acceptable because they asked me to leave it in exponential form. Of course, if they didn't ask you that, you could just work it out on your calculator. 2 to the 8 is not too bad. The next one definitely would be one I need the calculator for. It says, which term equals that? So which term? So term N equals 2, 4, 5, 7, 6. Term N will have the form AR to the N minus 1 equals 2, 4, 5, 7, 6. Right, now knowing that, let's just get this thing to extend. A little bit too much, bring it down. We know what A is already. A is going to be 3/4. The R is 2 to the N minus 1, and this is equal to 2, 4, 5, 7, 6. Right, now, if we're going to solve an exponential equation, which is what this is asking, you can remember back from grade 11 that what we try to do is get the bases the same on both sides, because then we can equate the exponent. So looking at that, I would times this side by 4 and this side by 4, and I would divide this side by 3, and I would divide this side by 3. So in actual fact, that falls away. So I have 2 to the n minus 1 equals, and over here 3 will go once, and into there it will go 3 into 24 goes 8 times, once 9, 2, and then 4 times that is going to be 8, 6, I'm being very good without my calculator today, 7, and 2, 4. Now what I would have to do is write this as 2 to some exponent. Now you're going to do a section this year called logs, and logs will enable you to work that out a lot quicker than what I can do now. So what I would do is I'd go to my calculator and I'd take an educated guess as to how much the exponent was. So I bring up my calculator, I clear it, and I'd say let's try 2 to the exponent 18 and see what happens. Right, it's not quite 2, 6, yeah. So let's divide by 2, see what I get. No, so obviously I've done something silly. Of course, there is another way I could do it. I could take this number and prime it, but again, it would take quite a while. So I'm not going to do it because I want to mention a little bit about a question that was mentioned to me in the break. So it's 1, 2, 3, 8, 4. And you keep on going, 2 again, and you work it out like that. Perhaps that's the easiest way. But anyhow, whatever you get over here, whatever it might be, we are going to then say, okay, since they both are power base 2, I can equate the n minus 1 equal to whatever I found up here, and then I can solve. So it's really not a problem. Just quickly, I want to mention, because I see I'm running out of time, the question that came in, and I seem to remember something along this line, it says the first term is 5 times the third term of an arithmetic sequence. Find some other term. Now again, coding will work. So what I'll try and do, because I see we really are running out of time, what I will try and do is I will look at the question and see if I can sort of incorporate it somewhere, a similar kind of question in the next session we do. But basically what I would do is I'd go T1 equals 5 times T5, and then I would change the T's into the formulas. And then hopefully I get an expression that I can simplify down and solve. But I will get hold of the question and have a closer look. So sorry we ran out of time. Sorry, hand over to you.
All right. Thank you so much, Lee, for joining us and for giving us such a great lesson. Everyone thinks you're clever on Facebook.
They're also clever.
Yes, yes, they're going to be just like you one day. Mindsetters, thank you so much for tuning in. Thank you for joining us on this very first day of live shows. We will see you again next week. And as Lee said, we are continuing with this topic. So make sure you do tune in and you go download the notes, guys. Our notes will be ready in a set amount of time. So make sure you check out our website, learn.mindset.co.za. The notes will be there for next week as well. So make sure you check that out, and we'll see you soon. So goodbye from us.